It's live. Sweet. Great. Everything seems to be working. Trying something a little bit new today. I am recording stuff through OBS at the same time. Hopefully we'll be able to get out maybe some shorts for some like Rust language content. I think that would be pretty cool. I have no idea if it's going to work. I have no idea. Well, I know what the workflow is going to be, but we'll see. So today is more Rust language workshop stuff. In this case, we have been working through some Rust, like introductory Rust content here, right? So this is basically what we have so far. There's a whole intro that is kind of not something I'm going to go over right now. We've got a whole, I don't know, 13 pages of stuff. Hey, Cameron, how's it going today? How's your morning going? Or if it's morning for you, I mean, it's morning for me. So we've got this why Rust section that I kind of still need to fill out. I don't have a, let's see, cargo. Add a little TK there. So there's all of this like why Rust, what is it used for and stuff is gonna like one section of stuff. So maybe we put a page break after this just to make it a little bit clear when we're working on stuff. I think this is how you do a page break in Typist. Tipst. I don't know. I never say it correctly, I guess. Pages break isn't what I want. I do have a terminal just like rebuilding this all the time. Cool. So like why Rust is like its own section, right? And then introduction to Rust is like this less than 30 minutes amount of content for how do you get into Rust at all? We start with, let's see. There's a little thing here. I don't know, maybe I want to rephrase that, but I definitely don't want that little eye hanging out there. Hey, Robbie, how's it going? Still morning up here in Seattle, planning on getting through chapter 10 today. Nice. Of the Rust book, that is? What is chapter 10 of the Rust book? Generics. Nice. So generics, traits, and lifetimes. That's cool. That's a big topic. Hey, Saucy, how's it going? I also just added Blender 5 support to Skeen this morning, which was cool. It was like a one-line change. I don't know, gonna be honest, I don't know why that line had to change, but it did. So I changed it, and now it works. There's a whole bunch of reasons like the why Rust and what Rust is used for has to like target somebody specific, right? And right now, it's kind of somebody who is not sure that they want to write Rust, have heard some things about it. Maybe they've heard good things, maybe they heard weird things, who knows? And they're kind of like, okay, what is Rust? What is it about? Why would I use it? What is it used for? And my main point in all of that content is basically going to be like Rust can take you wherever you want to go, right? Rust is kind of uniquely positioned to do very high level stuff, very low level stuff, and like this whole spectrum of things in between. And that is a really useful thing to have in general. So you can do web applications, you can do physical devices, you can build, standalone CLI programs, you can do web front end stuff, you can do a kernel, like all of these things. And Rust can just be there for you. And then like things like cargo are also super important. Like I don't want to use a language that doesn't come with a package manager and an auto formatter and a linter and like testing built in and like all that kind of stuff. Followed by like one of the things that I vaguely remember, because it's been decades for me since I learned how to program, But one of the things that I remember learning a long time ago is I couldn't tell what language was used for what or what it could be used for. So I imagine that there's a bunch of people who are like, I don't know, we'll say like halfway through their first programming language, who are like looking at Rust and going, I don't know why I would use some other language. I don't even know what another language can do, right? If you're using JavaScript, it's like fairly obvious that you can build websites, right? If you're using maybe something else, maybe it's clear that you can do a specific thing, but it's not like, it's hard to just like hear Rust is a general purpose language or Python is a general purpose language and understand anything about what that means. The cultural documentation is also a plus for inclusivity. Yes. Yes. That's part of like, I'm including that in Cargo. Because the list of Cargo subcommands is kind of like all of the stuff that Rust just comes with and is there by default. And that has, maybe I'll make a note for myself, talk about like Cargo's impact kind of like on the ecosystem in general. Morning, Zeno. How's it going? The culture of like just having documentation built in is huge, right? Because there are other languages that don't have that, right? Rust has it. JavaScript doesn't have it, right? There's no like documentation tool for JavaScript. There are a plethora of like third party crate like applications that you can use to make documentation. But having one thing that is like every crate is documented like this, all items can be documented like this, it all builds into this like uniform format. That is a huge thing. So then we got into the introduction to Rust, which is kind of, I think this introduction line needs a rewrite. This doesn't feel good. But that's fine. So it's basically like you can either use the Rust playground, which we have a link to. There's a screenshot of what it looks like. If you don't want to install Rust, you can just go get started. Most people will probably actually install Rust. We'll talk about RustUp. We'll talk about what RustUp does for managing Rust versions and tool chains and the associated tools that come with that. Only very briefly, in a sense, right? We mentioned that RustUp can manage Rust versions. We don't really talk about what an edition is. We don't talk about like the Rust release cycle at all. We really just say that RustUp can manage Rust and its associated programs, things like RustDoc, Rust format, etc. If you want to compile for different targets like WASM, RustUp will help you do that. And then we get directly into Cargo. And Cargo is super important, right? Cargo is the package manager, but that's really, really underselling what Cargo is. Because in addition to being able to install a new package, it's got all these things that we just talked about, like documentation and testing and linting, and it calls out to Clippy and Rust format and et cetera. It's got testing built in. It's got, you know, I want to say benchmarks, but not really. I feel like benchmarks are in this in-between area where like I don't really want to mention them. But there's a whole suite of community Cargo subcommands that you can install and just start using that do various things, right? If you're going to do embedded microcontrollers, you can install ProBAR-S and just like Cargo run like right onto a microcontroller over USB. It's really cool. So mention a couple of those subcommands, mention one of the like community-based subcommands. Again, we only really have so much time. This is going to be a less than 30-minute set of content. So we only have at most 2 minutes per heading. Then we get into Rust Analyzer. Rust Analyzer also comes from RustUp. That's how you do IDE back and forth, right? We mention inlay hints. We mention type checking, diagnostics, code, like code assist, like fill match arms, things like that, code completions, refactorings, etc. As well as being able to trigger like auto formatting on save, things like that. Basically anything you would expect from like a modern like LSP IDE experience. So we've talked about how to install it and like what you kind of get, and then we jump directly into starting a new project, and that's with Cargo New. So we've just talked about Cargo. You should kind of be familiar with the fact that it has subcommands. We talk about running one with bin. We don't mention lib until later. We go with Cargo New -- bin with a package named Quick Start. We don't really talk about crates yet. We don't really talk about like the difference between a crate and a package. Talk a little bit about source main.rs, how to run it, dev versus release, like debug profile versus release profile, and what impact that can actually have on a running program. We give an example of a program that you can run in dev and then in release and see an actual runtime difference. I think mentioning release is super important because it's kind of a thing that a lot of people forget, and then they go, "Oh, my Rust program is slower than, you know, X Python program or, you know, XC program or whatever," and they just forgot to like use the release flag. So this program doesn't do a lot, but it does introduce like at least 4 new concepts, I think. Variables, mute, ranges, the idea that you can have an associated constant like U32 max, how to do assign to mutable variables, formatting variables into strings. So it's like, it's a pretty dense code block if you come from it from the perspective of somebody who doesn't know anything about Rust so far. And that leaves us kind of like where we are right now, where we have the rest of the outline for that like 30-minute set of content. And then we have the full kind of outline for things to dive into more deeply. So we'll do, for example, error handling here, but we're not really going to talk too much about like all of the specifics. We're going to wait to do error handling down here to talk about how to actually build your own errors and things like that. Up here, we're just talking like 2-minute summary of error handling. Option exists, result exists, functions return them all over the place. Standard library uses them. They're not special, etc. So once we have a program running, I feel like we could either go one of 2 directions. We can either immediately go to here's how you pass like data into a CLI. What level of experience with non-Rust programming do you have in mind for the target audience? 1 language. So I think that is the delineation line. It's basically somebody who has programmed before. It doesn't really matter which language. It doesn't really matter level of experience. But you've seen things like functions, you've seen things like variables, right? You kind of understand that if you put something in the wrong place, you'll get a syntax error, right? This is, I think, if you're talking Rust for somebody who doesn't know how to program yet, that is a completely different set of content. And a lot of that content has to be, here's what a terminal is, here's what a function is, here's why we have variables, etc. Which is all stuff that like somebody who has written some programming language already worked through. So if we continue with the idea that we have now a place to run some code, we can either take the step of passing in user data, right? So cargo run whatever, our binary runs, we pass in something on the command line, we use that to run a program. Or we can jump into kind of structs and enums and stuff like that. I think I think structs and enums are an interesting topic, not from the perspective of like, here's the syntax for a struct, but the idea of sum and product types. And a lot of people aren't familiar with that terminology. It comes from functional programming, I think. But the idea here is that if you have a struct, you have a set of fields, and all of those fields can be set to arbitrary values, right? So if you have some struct, and I'm just going to call this my struct for lack of a better framing. We've got like A, which is an I32, and like B, which is, I think we're only going to use numbers for now because we haven't introduced strings yet. So we'll go with like I32 and F32, right? So the set of values that this struct can contain is every I32 as well as every F32, right? So it's like the combination of those two values, like the mathematical combination. Whereas if you have an enum, and you have like first and second, right? Fundamentally, an enum is about making a choice between two variants, right? You're either using first or you're using second, but they're contained in the same type. So it's really important to kind of get across that if you're going to build a struct, you can have a bunch of fields, and all of these fields can be set to arbitrary values within kind of their, I'm using imprecise terminology here because I'm not using like category theory terminology, which nobody's going to it's not going to work for anybody, but like within the same like scope, right? So like within the same, if I was going to make this like a U8, right? Numbers 0 to 255, as well as any F32. So like 0 and 1.0, 0 and 1.1, 0 and 1.2, 0 and 1.3, 1 and 1.0, 1 and 1.1. Like all of those values can be contained in what this struct represents. Whereas for the enum, it is either a number from 0 to 255 or a float, right? And that's the critical juncture for deciding which one to use. Are you making a choice between multiple things? Or is it a single domain, so to speak? So I think that's what I want to talk about. But I also want to say something along the lines of like use owned data types and structs. We kind of have to talk about structs to talk about ownership. I guess we could talk about string and string slice, but string and string slice are far more confusing than, I guess we could use vec. We could use vec to talk about ownership and kind of ignore the generics in vec, and then talk about how to make your own structs and enums, and then do string and string slice after that. The ordering here only kind of matters because this is like a quick run, right? So the idea here is that you are going through this video, you see some code, you don't necessarily understand everything on the first watch or the first read or the first whatever. It just introduces a bunch of concepts. You decide whether you think those concepts are interesting or not. And if they're interesting to you, you continue learning Rust. If they're not interesting to you, maybe you move on to some other language. It's not like meant as a filter, but it is offering, this is what Rust is. If you're interested in this, continue learning Rust. So with that in mind, do we need to talk about ownership before we talk about structs and enums? I think we can talk about vecs and integers. to talk about ownership. And then we can talk about data structures. I'm assuming some familiarity with if statements from other languages, because basically all of them have it. Although not things like let else. And then pattern matching comes in at some point, probably with control flow. Generics and traits, that's the chapter that you were going over this morning. Iterators has to come after generics and traits. We can talk about documentation and testing after that. Talk a little bit about how to read different documentation. And then that's kind of it. Unless I come up with another high-level heading that's worth kind of mentioning. I haven't thought about anything yet, but that doesn't mean I won't. I can always fit it in later. So I think we immediately start off talking about ownership rather than structs, right? So if we're going to talk about ownership, we haven't used anything yet. We kind of have to talk about vec versus like integers. And the point of ownership from the perspective of somebody who's coming to Rust, I don't want to show them too much like, here's negative code, if that makes sense. Like, here's code that doesn't work or breaks or whatever. So I would like to be able to explain ownership without being like, hey, look, this doesn't work. So let's start with where are we? Data is owned by one variable. I'm going to move this up here. Data has a single owner. This means a single variable is responsible for the life cycle of a specific piece of data. You came to Rust from C, so ownership felt like a familiar best practice done on my behalf. It's very easy to appreciate when you've been managing the heap yourself. Yes, I could see that for sure. I think that there's also a suite of people who are coming from memory managed languages, right? Coming from JavaScript, coming from Python, coming from Ruby. So one of the things that I'm probably not going to mention in this video is the stack and the heap. Because if you've already been doing that yourself, right? If you've been managing the stack and the heap, then you look at ownership and you recognize it. If you haven't been working with the stack and the heap, then it's just two new additional big concepts that you need to learn before you can understand what ownership is. So we're going to leave stack and heap out because the people who know that this solves their problem will know that this solves their problem, and the people who don't need to know. Two concepts to run away from for most people. Yeah. If I start off this section with stack and heap definitions or something like that, people are going to go, I don't care about the stack and the heap. I've never needed to care about the stack and the heap. Why is he talking about the stack and the heap? And the honest answer is like, you really don't need to care about the stack and the heap for like basic Rust, you know? Like if you're going to run Leptos and do WASM and web stuff, or you're going to do backend Axum handlers or something like that, you don't really need to care all that much about the stack and the heap, right? They don't need to be front and center concepts. If you're doing low level programming, absolutely. But ownership is more than just stack and heap management in my mind. Ownership is a compiler checked enforcement that I'm not mutating a variable from two threads, right? It's like I have a thing that is mutable and I want to do multiple things to it. And I want to be sure that some other random arbitrary part of my program is not mutating this under my feet, right? A single variable is responsible for the lifecycle of a specific piece of data. Let me make a note here for... This is going to be enough for me to remember. Yeah, John G's presentation on thread safe concurrency really got me with that. Yeah. Yeah. We're not really going to dive deep into concurrency, I don't think. We might mention like our iter or something in the iterator section. Right? Like because this is non-official Rust language content, we're allowed to talk about any random library. And Rayon is just like a really popular library that is totally valid to talk about if we're going to talk about, hey, you have an iterator and you want it to run in parallel. Here's some data parallelism. Rust's iterator trait enables that. Run par iter instead of iter. So yeah, in Rust, data has a single owner. This means a single variable is responsible for the lifecycle of a specific piece of data. Let's do a really simple example. Let's do... we haven't covered that Rust is an expression-based language yet. Do we need to cover that before ownership? We probably should, because immediately what I want to do here is show like a vec in a block and be like, if we put the variable inside of the block, then the variable's data is dropped at the end of the block. And we could do that with a separate function. Because like kind of what I want to do is like this, and then like let some data equals vec 123 or something, right? And like this is going to get dropped at the end of the function, but this is also like, it's obvious from the function signature that this is going to get dropped because we're not returning it. So it becomes a little bit weird if we're going to talk about ownership and scopes and things. So I think what I want to do is something a little bit more like this. Right? Debug some data. And then this gives you the, okay, well, there's like a block going on here. This is returning unit. This is inside of the block. We can talk a little bit about how like this vec doesn't live outside of the block, right? Not sure on that one. It's important, but maybe they would already know scoping in that sense. Yes, I think scoping is something people will know, right? But I want to use this scoping to talk about dropping specifically, because dropping is unique. And dropping is related to ownership, right? And I think what's forming in my head is basically if we write a separate function that creates data from inside of it, it's a little more obvious that this vec is not getting returned. Like, it's like, oh yeah, that's obvious. Obviously, I wouldn't be able to access like some data from like, you know, if I just called has vec, obviously I can't like access some data. It's not even in the same like area, you know? It's a little bit less obvious if we talk about it like this. But to talk about it like this, we have to talk about Rust being expression based in the first place because we're going to use these braces. So scoping, yes, like lexical scoping, people probably have experience with, for example. But we're going to talk about ownership and moving and copying. And I want to go, I think, from this expression like this into that function. And once we start talking about functions and things that return stuff, we're going to want to know that Rust is expression based. So I think expression based comes first, and then we write the ownership. Is there a language that's not expression based? Curious what the distinction is with that term. So the thing with Rust is that it is mostly expression based. I was looking for the Rust, not the Rust spec, but like the reference. Here's a reference. So Rust does have statements, right? But statements are not as many things as you would think they are in Rust. Basically, everything is an expression. And the big difference between statement and expression is evidenced by if. So if true, 1, else 5, right? And we can do like let result equals this. This is some gnarly computation that we did. And we have result here, right? Put this in the place that is easier to see. So when we say Rust is an expression-based language, what we mean is that Rust, for the vast majority of items that you're going to write, those items are expressions. If here is an expression, whereas in other languages, it's a statement and doesn't have a return value. That's really the key difference, right? The idea that because most things are expressions, they all return whatever is in that terminal place. So if true, return 1, else return 5. These are in the terminal places in their blocks, right? Which means that result will be always 1 in this case, because that's how I wrote it. Right, 1. And if this is false, this is true, 5. Right, 1 and 5, which is fine. That's totally cool. But the idea is that most people are used to this needing to happen. Right, and then inside of each of these arms, we would end up with result equals 1 and result equals 5. And like you can technically still do this, right? But you don't have to do this because Rust is expression based and will just return those values if you want it to return those values. So that's what I mean by the difference between being or like having more statements and being an expression based language. Basically, everything in Rust is an expression. See if I can find the official the official thing is a little bit more confusing, but I want to be precise when I say this. There are two kinds of statements: declaration statements and expression statements. Declaration statement introduces variable names, or not variable names specifically, just names into a scope. And Rust has a couple of different namespaces, like a variable namespace, a type namespace, etc. So item declarations and let statements and functions would be in item declarations. Can we find a specific? Let me click on item. So here's all the items that are technically statements. Defining a function. Registering a type alias. Defining an enum. Right? Defining a trait. And then if you look at expressions, expressions are all of the literals, blocks, all of the operators, tuple and array indexing, grouped expressions, right, via parens, call expressions, et cetera, et cetera. If is also in here, like we were just talking about, where if returns a value. Loop also returns a value, await returns a value, et cetera. Match returns a value. So if you're defining an item, you can consider that a statement. If you're basically, whenever you're working with code that is, how do I say this, executing, those things are usually expressions. And then that means that semicolons are actually a piece of syntax that is not just there for compiler disambiguation, right? In some languages like JavaScript, you have automatic semicolon insertion. We don't have that in Rust because the semicolon is actually an operator that takes an expression and effectively returns unit in that place. Let's see if I can find the semicolon. Expression statement, I think is what that's called in the docs here. An expression statement is one that evaluates an expression and ignores its result, and that is the semicolon. So the official language is ignores its result, but I kind of think about it as returning a unit. So you take all of these expressions, all of these if expressions, block expressions, you know, variable computations and stuff like that. Those all return values. And then you put semicolons on them to kind of ignore the return value if you're doing something else with it, like having a side effect or whatnot, or setting another value. But yeah, does that make sense, or was that too rambly? If you're defining an item, it's going to be a statement. If you are using code effectively, like using things inside of blocks, it makes sense to you, but you're a big programming nerd. Yeah. Well, that's why I'm not like, one of the things that I'm not going to do is start talking about declaration statements and stuff. And Rust as an expression-based language is a little bit of a shortcut to say, hey, all of these things return values, right? I think that intuitively, you kind of don't expect a function definition to like have a value, like let x equals this, right? Like you don't really expect this to work because it's just like in open space, it's the definition of a function. But like a closure would need a variable to be bound to or be passed into a function as an argument or something like that. So I think I'm going to stick with Rust as an expression-based language as the initial comment. Yeah, and that's what they use here too. So Rust is primarily an expression-based language, right? So I kind of dropped the primarily when I was talking about it earlier. Expressions can nest. Rules for the evaluation of expressions involve specifying both the value produced by the expression and the order in which sub-expressions are then evaluated. And they kind of present this as like statements serve to mostly contain and explicitly sequence expression evaluation. So saying it like that is a little bit weird. I think it's a little bit too technical of a way to phrase it for people who might know like one random other language. So I actually think this might be our demo for that. Where is Rust as an expression-based language? I'll add the primarily back just to have that caveat. But your gut feeling is that new folks might not to do with the knowledge that it's an expression-based language. I'm going to explain that. I'm not just going to leave it as like Rust is expression-based. I'm going to say, and expressions return values. For example, the if statement that you might be used to in Rust will return a value, right? This is going to be driven by the example. It is not going to be a thing that I leave up in the air and just say it's expression based and then we move on. So let's type out some of that explanation just to drive that point home. We did a for loop. I'm going to not talk about the for loop. Yeah, that makes sense. Do you think there might be a good way to show a code example that warms them up to the concept? I think this is actually a perfect code example. I think this takes something that most people are going to be familiar with as a statement, like if, that doesn't return a value in most other languages, and then shows that it actually does return a value. And then we can talk a little bit about why it returns a value, what these arms are, like that kind of thing. Like keep it, because they haven't seen that much Rust yet, right? They've seen this much Rust effectively. This plus Hello World have been like the two code blocks that we've shown them so far. So this code block already shows them like a bunch of new things. We didn't explain ranges here, right? We didn't say, maybe I should explain a little bit more of this code block. Maybe I'll go back and do that. I don't know that I'm really going to be like, hey, this is an associated constant. But I'll say that U32 has a set of values that like you can just access them in the max. So we'll go with Rust is a primarily expression-based language. feel like the code block should come first, so that people can try to read it, and then I can talk about. Rust is primarily expression-based language. This shows up in do we do the exact code example first? I think so. Rust is a primarily expression-based language. This shows up in examples like the one above, where the if expression returns either 1 or 5 based on whether its test is true or false. This contrast, well, I don't need to contrast it with other languages, I think. I think if you're a person who has written other languages that have if where it's a statement that doesn't return values, this is enough to tell you that this is different. If it is something you've seen before, if you're like a Lisp writer or something, first of all, I'm going to assume that your skill level is a little bit higher, that you've used a couple of different languages, that you're exposed to more ideas. But I think if you have that extra level of knowledge, then you don't necessarily need the explanation. Let's see, I want to say this makes semicolons not just a random piece of syntax, but rather an operator that takes an expression and ignores its result. I don't really think the like statement versus expression topic is all that important. So I don't know that I want to. I don't think I want to get into like let result is a statement. I do want to drive home that these expressions return the values that are in the terminal slot, because that's very, very important. And I think giving the expression name to that idea is very important. But I don't really care about, or I don't think it's very important to differentiate statements and expressions in general. Rust is primarily an expression-based language. Do you agree with all that? Yeah. Because like the point isn't to be like, this is an statement, this is an expression. It's to be like, this is what Rust looks like, right? We're still in like that 2-minute preview kind of window. This shows up in examples like the one above, where the if expression returns either 1 or 5 based on whether its test is true or false. This makes semicolons not just a random piece of syntax, but rather an operator that takes an expression and ignores its result. I don't know that that really lands here. Yeah, for a 30-minute window, as much jargon avoidance as possible is good. Yeah. Yeah, I mean, we'll have the opportunity to get deeper into it. We're going to do deeper dives into each of these headings. They're going to have their own videos and stuff. So like, we will have the opportunity to get into any of this that we need to get into. But this is very much like for people who might be casually browsing programming languages, you know? Not that everybody walks around or like hunts on the internet for like the next language to use. Can also link outs to the PDF for curious folks to make their own adventure too. Yes, absolutely. I think the PDF isn't going to actually be the primary distribution method for this content. It will be available as like a download, but this will all go, there will be text on the Rust Adventure website that is derived from the content I've written in this PDF. There will be a video, probably both on the Rust Adventure website and uploaded to YouTube with a link to the content back on Rust Adventure. So if somebody happens along the video and wants to read through it, they can go read through it on an HTML page. And then the PDF will also be available for download. So there's going to be a couple of different like multimedia consumption patterns to this. I've grown to really like starting in Typist for scripting. So Typist is kind of where I put all of my stuff first, if it fits, and then I move it to other places out of that like Typist document effectively. And when Typist can fully render HTML, I think I will just leave it in Typist and take that and then like render it to HTML, which I'm really looking forward to. I think V14, Typist 14 RC is out. I don't think there's a block. Yeah. Typist 0.14 entered final testing recently. This page is not going to load for some reason. Maybe their forum software is just slow. You'd think forum software would be better. It's had 40 years to be good. You don't think you'd call it random syntax in other languages either. Indicates a termination, doesn't it? It indicates a termination, but like when I say random syntax, I mean the feeling of needing to use them, right? There is, in JavaScript, there's automatic semicolon insertion. Affectionately referred to as ASI. But this is a whole thing where there's a whole set of rules for where a semicolon can be like inferred. There is a whole set of people who don't like writing JavaScript with semicolons, who try to avoid it at all costs. It used to be a bigger thing than it is now. I don't know why people stopped kind of arguing about this. It used to be a huge deal. Like it used to be like semicolons aren't necessary. We shouldn't use them because JavaScript has automatic semicolon insertion. We should just let the, whatever insert them for us because there are rules for it, which kind of makes them a little bit like random in that sense, right? Like semicolons do have some meaning in other languages, right? I'm not saying they're useless, but they definitely feel less intentional. And that's kind of what I was getting at. I'm definitely not going to call them random in a like a document, right? Like I'm not going to, you know what? That's a good point. I did write that. That's why you brought it up. I should not write that. You're right. I didn't say it was random in other languages. So I'm not like kind of casting aspersions here, but I don't think that whole section of that sentence is necessary at all. And you're right, Chris. This makes semicolons an operator that takes an expression and ignores the result. But I also think this sentence might be confusing, right? Because it's a little bit like, okay, if it takes an expression and ignores the result, which thing is the expression here? So I think this actually is a deletable sentence entirely. I think it's a distraction. You can see that kind of focusing on your most constrained view, like a mobile first web app would. Yeah, for the document. Yeah. You didn't know there were hardcore semi avoiders. Yes, that this used to be a really big thing. I actually haven't seen it so much recently. Now that I think about it, I think it's died out. But it used to be a really big thing that people were really into writing JavaScript without semicolons. And they pointed to things like automatic semicolon insertion as like a reason that you should do it. Um, but yeah, I've never I've never been partial to white space based languages myself, so I've always appreciated things like semicolons. I feel like I write a lot of Python for Skeen, actually, right? Like this is actually quite a decent amount of Python. Um, and for example, I just merged a PR to update to Blender 5. And for some reason, uh, if string in object no longer works in Blender 5. I have no idea why. So I'm using dir on the source now. But there's a bunch of little things like that that are kind of like, okay, like what is why? You know, like these effectively do the same thing. There's some details in this that I'm sure are the like relevant details, but like having the stuff that I'm writing change meaning based on the indentation is kind of like not my favorite. Um, let's do this maybe. I don't want to replace that. I just want to, I don't know why I wrote that in typist and then brought it out. So I want to use the word implicitly here. It's not really the last value. It's the value in that terminal position, right? There's a little bit more to write in this sentence, but I'm jumping ahead. So we could Right, because I don't really want to get into like, oh yeah, multiplication is an expression, and like thing times thing is an expression, and this is an expression, and that, like, I don't want to get into the specifics too deep. I just want to get the general vibe of like most things are expressions, and that means that the last value is going to get returned, which means you can do things like complex variable instantiation. We haven't talked about like hash maps or anything yet, so I'm still kind of trying to stick to numbers. We could throw a hash map in here and kind of be like, here's our hash map. We're going to insert a bunch of keys and values, and then we're going to return the hash map in this result. You like semicolons. They're like periods at the end of a sentence, even though technically they're not. Yeah. I mean, I could see that. It definitely helps like visually tracking, I think. Like this is the end of that thing, is a useful syntax. This pattern can be used to encapsulate complex data initialization. Without leaking intermediate variables into the rest of the code is the way we'll frame that. Expressions return the last value. I'm not happy with the way that I'm framing that. What does they frame it as? Always produces a value and may have effects. I kind of like that framing, actually. An expression evaluates to a value and has effects during evaluation. I don't think we need to get that specific. Not going to talk about precedence. So expressions can produce a value and will return the last value produced. In their scope? I don't know that we need to say in their scope. Would you just link to an authoritative source for basic definitions, or is it more important to be self-contained? I fear that sending people to the reference is scary, but we could definitely include this, right? Like we could definitely link to, you know, like this. Like expressions can produce a value and will return the last value produced in their scope. So if somebody wants to get deeper into, because this isn't a reference, right? This is not enumerating everything about the Rust language. This is giving people kind of a feeling for what it's like. This is like a less than 30-minute intro to see if you would be interested. So if you're reading this and you're like, oh, I would love to know more about the specifics of expressions, we can definitely link to the Rust reference for more of that context. But this is also not a light read either. Yeah, I'm absolutely going to use my own words to like describe what an expression is in this context. But we can definitely link to the reference. Are there other things that we have already written that should link to the reference? Is the question in my head? I don't think so. We could link to the package manifest for cargo. You know what I should really be doing is building up the bibliography and then using those for links. That's what I should be doing. I'll do that later. I do think that linking out to this for people who want to dig deeper on their own is a really good idea. I hope these links don't break over time. Did we do this for the? I think we do this on binary entry point. Right, a Rust package can contain multiple binary entry points that links to this section of the cargo manifest, which says here's how you would configure and all of the places you can put binaries and all of those things. So if you really want the specifics, you can go to that. Otherwise, you can just keep watching the video or reading the document. Link, but also included summary is supposed to, yep, absolutely. I think that linking to other either authoritative or even useful content would be good, right? There's no reason that this needs to be like completely isolated from the rest of the world, if that makes sense, right? There are a lot of different places to learn how to do Rust stuff in a lot of different respects. This just happens to be the way that I think things should be ordered, the way things could be explained, etc. But there are other valid places for that content as well, right? There's also a course by Google that's a little bit more focused for Android development. There's a couple of other, like there's the Rust book itself, which is like authoritative, but the URLs might change a little bit too much. I guess not really, but they don't have permalinks, I don't think. That's one of the things that makes me a little bit nervous. There's no permalinks on any of these pages, as far as I know. So we're just kind of hoping that they don't go through and like do a full like reorganization of this content ever. It's not like I can link to like the Rust 1.90 version of the Cargo TOML. Okay, Rust is primarily an expression-based language. Expressions can produce a value and will return the last value produced in their scope. So in this case, for example, we could write a block expression. This is a new set of stuff. For example, we could write a block expression that defines a variable and then uses it to do some math, then returns that value. This pattern can be used to encapsulate complex data initialization without leaking intermediate variables into the rest of the code. Right? Like A is not going to be accessible by the debug macro. I'm debating one of two things. One is we haven't talked about like hash maps or anything like that. We haven't talked about more complex data types. So I think that using numbers here, like people can kind of be like, oh yeah, I could stick a hash map in here, or I could do a, whatever, vec initialization, or do a whole bunch of stuff in this block. But the point here is really that these blocks return values and to just get people used to that idea. So is this enough for that point to be driven home? Because we'll talk about it more as we move forward. So Rust is primarily an expression-based language. This shows up in examples like the one above, where an if expression returns either 1 or 5 based on whether its test is true or false. Expressions can produce a value and will return the last value produced in their scope. I don't think we need to mention side effects yet. Like technically, yes, expressions can produce a value and also have side effects. Hey, Chris, I'm so flabbergasted that you aim to fit the content into 30 minutes. We'd love to have deep dives into each section. We will do deep dives. We're going to do deep dives. This section down here, we're going to get to this chapters section that I have. So if you read this outline, there's basically like why Rust, introduction to Rust is this like 30-minute section alongside the Rust Quick Start. So introduction and Rust Quick Start are like the same kind of thing. They're just separated out here because I think that makes more sense in the outline. And then we'll get into like introduction to the Rust language. This will come with a short cheat sheet. And then we'll talk about all of these things will get their own section, their own full section, like not the 2-minute whatever section. The table of contents will take 30 minutes to read through. Yeah, I know. It's a real challenge, but I also think it's incredibly valuable because a lot of pedagogical technical content doesn't put the effort in to eliminate things that are unnecessary, preferring instead, for a less charitable take, the author is kind of like proving how much they know by listing all of the definitions and things. For a more charitable take, it's just kind of like easier to, I could open the standard library here, for example, and I could go, okay, the Rust standard library, right? Here's a bunch of stuff. Here's a bunch of things. Here's a bunch of the types that we need to talk about. We could talk about each of these modules in turn. We could talk about each of these macros in turn. We could talk about, like, et cetera, et cetera. It's a little bit easier to do that kind of thing, which is why it's a little bit more popular. And one of the things that I try really hard to do with Rust Adventure is bring things down in time, because I've done the math, and if there are, so here's the math. I've actually already done the math. I have it in my head. If there are, let's say 10 workshops on Rust Adventure, right? Let's say each workshop takes 1 hour. Right? Pretty short workshop, 1 hour. The average person who is kind of doing this in their spare time might have half an hour a day, right? Might have half an hour a day, might have the ability to do like 10 minutes of video content plus some exercise a day, like max, right? If they have a job, if they have kids, if they have whatever. So if you're talking about 10 workshops that each take an hour, and that each person is going to approximately get through 10 minutes of video content per day, plus whatever, written exercises there are, then you're saying that for a 1 hour workshop, if you can get through 10 minutes, that takes you a week to get through, right? About 6 days, 10 minutes. So if it takes you a week and there's 10 workshops, that's 10 weeks. And this is for like a 1 hour workshop, right? 10 weeks is 2.5 months, right? So once you start talking about 2.5 months, you start talking about like, oh, this happened over December break and they had to take a week to do something else and didn't quite get back to it, right? So we'll round up to 3 months. So if there are 10 workshops and they take an hour to get through each, that is 3 months of time, right? Realistically, there are workshops right now on Rust Adventure that run for 2.5 hours of video content, right? The Bevy ones specifically tend to be a little bit longer. So if you say that you're going to double the workshop time on all of those to 2 hours, you're now literally talking about 6 months of content, right? Which is like literally just a wild amount of time to expect somebody to commit to stuff, right? And that is like consistently doing a lesson every day. So this calculation sits in the back of my head all the time. This is like, because one of the things that I've seen from other courses, like I'm a multi-decade programmer too. Like I've done a whole bunch of courses, right? There are other courses and other workshops and stuff that kind of pride themselves on like how many hours of content they have. And if you tell me that you have an 8-hour or like a 42-hour like workshop on DynamoDB or something, your 8-hour workshop is going to take 3 months to get through, right? It's either that, or I'm going to be fast forwarding at 2x speed, trying to watch through everything. And like, at that point, it's kind of like you're putting the strain on the learner to organize the content that you basically have not organized if it's like an 8-hour like course, right? So one of the things that I really try to do with Rust Adventure is I kind of expect that you might have to view the videos 1 or 2 times. Maybe you watch the video and then you read and work through the actual material. That's a totally valid approach. But like a lesson is going to be 5 to 10 minutes to fit into that time period. And a workshop, if a workshop goes over like an hour, it's probably multiple workshops. And doing like a 4-hour workshop is just totally off the table, right? Like that is just, because like if you start doing multiple of those, it starts getting up into like 6 months. You know, it starts getting into so long for people to actually get through stuff. And the point of producing the courses and the workshops is for people to actually learn it and then go use it. So like, if you're telling me that like, hey, if you're going to start today and it's going to take you 6 months to get through all this and then you can write like whatever you want to write, like that's too much. What if you showed the bad version of the code to help make it super clear? So more lines of code and leaking intermediate values. It's a trade-off with a bias towards showing the right thing to do, right? If you write, for example, a blog post and you show the bad code, there are people who come in and read and skim, and they will miss the good section and they will see the bad section. I've seen this happen numerous times where somebody goes through a blog post and there's like a bad version or an incorrect version or a version that doesn't quite have all of the pieces to it, right? You get the code block, and then over the course of the next 5 paragraphs, it adds 2 or 3 more lines of code that are critical. You will end up with people copying that code out or try to use it. And they will just not get the value out of it. What about things like exorcism? I really like exorcism. My issues with exorcism are mostly around the fact that when I went through it to do various things, the feedback that I got from people in general on the code that I was writing was not helpful and was often very, very like, I don't care why you wrote it this way, you wrote it wrong. I think that exercises are really good. I would love to build some, I've experimented with building infrastructure that would let you do exercise-based stuff on Rust Adventure. I haven't deployed any, well, I've deployed it, but I haven't shipped any of it. Because the other thing that waffles in my head is like, if you're doing something like this, is building all of the infrastructure and maintaining it necessary? Or do you just ship it and let people run it locally? Yeah, so like Rustlings lets you just pull the repo down and get examples and run through them, right? I think that is probably a better approach, but it does leave out things like somebody who would want to do all the work on the web. It also leaves out, like, there's something really interesting about being able to give people a bunch of examples that they work through and then seeing the actual answers. So like if I had all the answers for an exercise in a database somewhere, I could pull those up, look at them all, see what mistakes people were making, and then modify the educational content to address those mistakes. That's really interesting. But yeah, I've looked into this kind of stuff for sure. I think Rustlings is a really interesting approach. I think that Rustlings falls down in that it doesn't include pedagogical content alongside the exercises. So you kind of are left on your own to figure out like what the answer is supposed to be, which is why I have a Rustlings video on this channel, by the way. I have a multi-hour Rustlings, like I went through Rustlings version 5 dot something or other. I did all the answers. I talked through all the exercises. And people found that really useful because there's no pedagogical component to Rustlings. It's just kind of like, here's an exercise and here's the answer we expected you to get. But historically, there hasn't been a lot of explanation there. So Rust is primarily an expression-based language. It shows up in examples like the if expression. Expressions can produce a value and will return the last value produced in their scope. I think this is good enough. I don't love the explanation, but it does drive the point home if you're not familiar with like what a terminal position is or like what a etc. Like the thing that is last or the last thing to be executed is the thing that gets returned. So we could write a block expression that defines a variable and then use it to do some math and then returns the value. This pattern can be used to encapsulate complex data initialization without leaking intermediate variables into the rest of the code. I think that that's a really good idea to communicate. I think that this doesn't quite show what a complex data initialization would look like, but I don't think that's necessary. I think if you're a person who's programming and you're like, oh yeah, I've had to like initialize a hash map with a bunch of values or do some processing before, you can just like mentally reinsert this here. So we've talked about, I think, expressions at that point. So now we can mention expressions and all of the rest of the stuff. I don't think expressions, where's control flow? Do we have another control flow section? Not really. I think at some point we're going to need control flow. Probably around pattern matching, right? Like control flow and pattern matching and stuff like that. I really want to mention like match. I'm less concerned about patterns like let else or while let or whatnot. Well, we might talk about loops and stuff while we talk about iterators, so we can kind of leave that for later. Okay, so we've got expressions. Ownership. Ownership, I think we can cover ownership once we've talked about expressions, right? Our ownership example then builds on the example that we just had. I don't think it builds on it, actually. So this would be a counter example, right? I don't really want to write the counter example. I feel like we kind of have to. Maybe we start off without this. We haven't introduced vex yet. But I don't think that that really matters because every language has like a list or a vec type. And we are assumed that people know some other language. I think we've narrowed down to vec based on the things that we've already covered. Single variable is responsible for, it's not really the single variable that's responsible for the life cycle per se. But I think this is a fine mental model. It's like one of the things that I see people trip up on in Rust quite often is not understanding what it means to be passing around references and stuff. And if you drive home that there is an owner of your data, like your data lives somewhere. It's in a variable. It is somewhere in your program, like something owns it. Then you can start kind of talking about, okay, well, if we just want to view things into this, then we can use a shared reference. If we want to mutate things, we can use an exclusive reference. But if that data ever moves or drops, then the thing that we're holding doesn't work anymore. And Rust's ownership model kind of prevents that from happening, right? Something can't drop while you're holding it. I don't think we're going to talk about lifetimes. I think we can ignore lifetimes until later. Let's do 2 debugs. So let's start with like, let's not call this variable data because I'm going to use data to talk about what it actually is. So let's talk about this as numbers and not data. because otherwise it'll start being confusing very quickly. We'll do a short shout out to Vec, right? So what do we officially call Vec? It's like a dynamic array or something like that. Continuously growable array type. I don't love that explanation. A Vec is a Vec is a list of data that can be added to or removed from, right? I think that covers it without getting into like what a contiguous growable array type is. When using the Vec data in our application, we need to share references to it, which retains ownership of the data in numbers, or we can move it to a new owner. I don't know if that's the next sentence, but that's something we have to cover. The numbers variable owns the Vec data. A Vec is a list of data that can be added to or removed from. The debug macro takes ownership. So in this case, we move the data. This means that calling debug twice would fail to compile. Initially, people finding ownership challenging since it can make their code not run. Is it worth highlighting the significant benefits? Yes. That is what I want to do. I guess I have a question about how you would phrase the significant benefits, because the way that I'm thinking about it right now is that ownership basically makes it easy to determine which piece of your program is actually accessing a particular piece of data at a given time. So you can't get yourself into situations where a variable is being mutated by two different pieces of your application and thus changing under you. Right? I think they use data races in the official, or rather, I guess this is the Rustonomicon. Data races are prevented through Rust's ownership system alone, mostly. I'm probably not going to talk about send and sync, not until we dive deep. You'd say it makes it harder for you to screw up and easier for the compiler to catch your mistakes. Yes. I think that's basically the same as the thing that I want to communicate. This is a little bit about concurrency. So like mentioning data races doesn't really land unless we've talked about threads and stuff. Oh, they have a whole section on ownership in here in the Nomicon. The breakout feature of Rust. We'll assume that you accept that garbage collection is not always an optimal solution. If it is, I guess you're writing another language. I think a lot of this ends up talking about C and C++. And I really don't want to do that. I think that people who write C and C++ can figure out from what I'm saying that this is what happens. This is a good example in general, and something actually that people try to do and don't understand why it doesn't work, right? Creating data inside of a function and then trying to return a reference to that data because they don't understand where that data lives, right? That's part of why I was starting off with this owns that data, right? Because we can get into this. Right? Does this actually just fail to compile immediately? Of course it does. But I want it to compile for the right reason, or fail to compile for the right reason. Yeah, returns a reference to data owned by the current function. This is another thing that I want to drive home in some way, but I don't want to have too many counterexamples. The error messages in Rust are really, really good, right? There are situations in other languages where it's like almost not worth reading the error messages. And people kind of teach themselves to skip all the error output because the error output actually doesn't help them debug things. But there has been so much effort put into Rust's error messages. It's like move occurs because numbers is a vec of I32, which doesn't implement copy. It's moved into debug here, and then you try to use it again after it's been moved. If you have like light context here, right? I'm not like, if you don't know what copy is, this gets more confusing, obviously. I'm not saying this is like perfectly readable to everybody. I'm saying that this is a good error message for somebody who is a Rust developer. Okay, but we're not there yet. Takes ownership of the data. So in this case, we move the data. How do I highlight that this is a failing counterexample? I feel like I need to have a special code block style. I don't want to say the first debug owns it, but that's kind of true, right? Like I've kind of said that like a variable owns this, and it doesn't quite track that a function would own it. So maybe I don't. Maybe I reframe this away from variables as the owner, like a single variable owns the data. That's really good for the initial understanding, but it kind of immediately breaks down. Because like we're moving ownership into this function, right? And like, yes, the function has a variable that is an argument that then like owns that data. But the talking about it this loosely makes it feel a little weird. Because calling debug twice here would fail to compile because the first debug it's like the cause and effect here is getting a little bit messy if you really know what's going on. But I think for somebody that doesn't know what's going on, this is like this kind of loose explanation is enough, and it's actually the correct way to do it. Because calling debug twice would fail to compile because the first debug moves the data out of the numbers variable, which means it's no longer there for the second debug to access. This is not really a good example of like when it prevents you from making an error, because this feels to somebody who is not used to ownership as like, yeah, why wouldn't it just clone it? We haven't covered macros. We've covered print line, but we haven't covered macros. So I think that's a good point. We kind of do have to print the numbers out, because if we don't, one of the things that I've come across is basically like if you don't print the numbers out, then people can't check the work, right? So they have to be able to run this program and see some output. So we have to use a macro at some point, but we can put this macro inside of the other function. What do we call this? I don't want to call this something that overlaps with the terminology I'm going to use. I want to call this prints numbers. We'll name this different than we'll call this vec of numbers, and this will just be an I32. And then we'll use debug on vec of numbers here. And then we still use debug, but really we're showing the explicit types here. Right, so this prints out, which is great. So let's get rid of this and do this instead. We're not going to say the debug macro. We're going to say prints numbers function takes ownership of the data. Compile errors also count as output. Ownership issues are caught at compile time. Yes, I agree with that. I I am extremely sensitive to the idea of like, if you run the program and it doesn't do anything, you don't know that it succeeded. Right? So if we didn't have this debug here and you run the program and you don't know anything about Rust and it doesn't produce any output, right? If you do this and you run and it's like, okay, the program ran, did the data get written to a file? Did it get sent somewhere else? Is there somewhere I can see it? Like, yes, the program ran. Yes, it compiled, but it didn't produce any output. So it's hard to be sure, if you're not sure what's going on, that this actually did something and didn't just compile, right? We are about to have a failure too, right? This is going to be prints numbers twice, and prints numbers twice is going to fail. So a vec is a list of data that can be added or removed to. This is a main function with a function that takes a vec of i32s. I think that people who know a programming language can tell that this is like an argument with a type. I don't think I need to explain that. Especially in this like sub 30 video. So when using the vec data in our application, we can either share references to it, which retains ownership of the data in numbers, or we can move it to a new owner. The prints numbers function takes ownership of the data. So in this case, we move the data. That means that calling print numbers twice would fail to compile because the first print numbers moves the data out of the numbers variable. We'll say like into it's not really a variable per se, but I think that's close enough. Which means it's no longer, I don't want to use words like there. So calling print numbers twice would fail to compile because the first prints numbers moves the data out of numbers variable into the vec of numbers variable, which means it's no longer in, it is no longer in numbers for the second prints numbers call to access. So this gives us a whole bunch of output. I think coming back in here and doing colorized output was probably a good idea. I think the colors are pretty relevant. I do have some color functionality here, but I'm going to have to come back in and fill this in. Right, we can grab all the ANSI stuff and actually stick it in here so that we actually do get the colors that I would normally see, or like relative colors, which is like how you would normally see it. Where is our table of contents? We are in data. So data is owned by one variable. In Rust, data has a single owner. Show this program. Here's the output. We need to make sure that this is all like on the same page, I guess. I don't know. It feels weird to like have two pages to look at this. So I would want to make sure that this went to the next page if it was overflowing. At some point, I'll go back through here and I'll do like a, not a formatting pass, but like make sure everything is on a reasonable amount of space pass. Reading over the edge of a border is kind of weird. This code will result in a compile error. The compiler warns us about the program having moved the data. While also providing suggestions for how to fix that. You'd love a Bevy version of the video, kind of what 3 Blue 1 Brown does, with name variables being variable names, ownership with boxes being owned, and so on. For your nephew, for example, but they are too young. I don't know why I would kill you for that. But named variables being variable names, ownership with boxes. There is some tooling to do that kind of thing. There are people who have experimented with this. I think the output doesn't look good for most of them. And I think that it doesn't necessarily pick up on everything. But there is tooling to like generate visualizations like that. You kind of do have to learn how to read them. Here's another one. But it is kind of hard to read, you know? I really like that people are experimenting with this. I don't particularly love any of the output that I've seen in general. Like value moved function call on string from. I mean, technically, but is that useful? You love a Bevy version of the video kind of look. Are you talking about just like the... Do you have a specific 3 Blue 1 Brown video in mind? Because I've seen 3 Blue 1 Brown with all the linear algebra and stuff. I get kind of what you're getting at. I do think that I would like to do more visualizations like that in more of my videos. Again, the issue is time. So the issue is basically like, do I make one video this month and do a bunch of visualizations? Or do I make, 4 to 12 videos this month? With maybe not as many visualizations, but working code and examples and everything. Yo, Joda, how's it going? I guess, is it Joda or Yoda? You mean a video where a duck, a variable, tries to take ownership of a 3D cube, and another variable, a fox, tries to access it mutably as well and fails with red color and error whistle? You mean like visualize ownership through Bevy concepts? Yeah, I mean... It's an option, is the way that I'll frame it. I've got a lot of thoughts. That's why I went deep in, in thought at that moment. A lot of thoughts on that kind of stuff. We will have to make a video on ownership. There will be like a dedicated video on ownership. So it's worth examining what kind of visualizations work well in that video. Right? Right now, I'm basically writing out a bunch of code and a bunch of content. But this isn't necessarily like the way that it needs to show on a video. I will say that people seem to really like videos that are basically formatted like slide presentations. I don't know why, but effectively, if you make a PowerPoint or a keynote or whatever, people tend to really like code videos that look like that. I don't have the answer for why, but all my videos that are basically talks that I would give at conferences do really well. So this code will result in a compile error. The compiler warns us about the program having moved the data while also providing suggestions for how to fix that. In this way, Rust will, at compile time, guarantee that you don't have multiple, like your data isn't changing out from under your feet. In this way, Rust will, at compile time, guarantee that your data isn't changing out from under you while operating on it. Ownership makes data access and lifetime issues a compiler checked data access and lifetime issues. Is that going to connect? Data access and lifetime issues. I don't think that's going to connect like I want it to connect. In this way, Rust will, at compile time, guarantee that your data isn't changing out from under you while operating on it. Because the compiler knows which functions are taking ownership, which are mutating it, and which only have read-only access. Ownership turns this problem into something the compiler can check for you instead of something you need to keep track of in your head while programming or doing large refactors. Does that make the impact that I want? What do y'all think? In this way, Rust will, at compile time, guarantee that your data isn't changing out from under you while operating on it, because the compiler knows which functions are taking ownership, which are mutating it, and which have read-only access. Ownership turns this problem into something the compiler can check for you instead of something you need to keep track of in your head while programming or doing large refactors. Right? I think driving home, like for simple cases, it's possible to keep this kind of stuff in your head. But once you start working in like a production application, once you start doing large refactors, once you start passing a bunch of data all over the place, then having it be like a thing a computer can check for you instead of a thing you need to like memorize and remember that Joe last Saturday made a PR to change how that works. This yields huge benefits for teams, which can merge PRs knowing that if there's an issue while rebasing a separate refactor, that the compiler will keep track of the issues for you. This yields huge benefits for teams which can merge PRs, knowing that if there's an issue while rebasing a separate, knowing that one person's merge won't silently invalidate another person's data usage. The compiler will keep track of the issues for you. Does that connect with people in chat? Like, if you are using Rust and taking advantage of ownership because you're using Rust, then multiple people making multiple PRs to the same project can all make those PRs and not have to, like, as a group, tribally memorize the way that different access patterns are happening, because the Rust compiler will just check this stuff for you. So person A can merge, person B can merge, and person C can see that the compiler is now saying that, a mutable reference or an exclusive reference is being held over here. Therefore, you can't actually access it in this way. I feel like that's an undersold piece of the ownership puzzle. It's a lot of talk about like memory safety, or a lot of talk about like keeping track of things on the stack and the heap, but it really is like confidence in being able to make changes, because you don't need to memorize all of the internals for a constantly changing code base. So when it comes to our example that currently has a compile error, we can fix it in one of two ways. Fill in the data, creating a second, I always have trouble saying this, creating a second copy, but not like the copy trait, you know? Creating a second duplicate value with a different owner, or share a reference. Which allows a function to temporarily access the data in read-only or mutable access patterns. Compiler checked access patterns. So cloning is this, which needs to be on the first one. Is it the ownership issue? Fixing the... I don't really want to refer to this as like a problem necessarily, right? The compiler warns us about the program having moved the data while also providing suggestions for how to fix that. So when it comes to our example that currently has a compile error, we can fix it in one of two ways. It is a compile error, so I mean, we kind of have to call it that. Cloning the data allows us to pass a duplicate value into the first function while moving the value in numbers into the second function. This is a good option if the values are lightweight, if multiple copies are needed. Is there a third answer for this? Good option to clone if the values are lightweight, if multiple copies are needed. I think 2 is fine. Maybe an additional heading here. Right. Sharing a reference provides temporary read-only access Sharing a reference provides temporary read-only or mutable access to the value in numbers. I guess passing a reference. Because I want to keep shared references and exclusive references for shared data and mutable data. Like, there is the vocabulary in the world that these are referred to as immutable and mutable references, right? An immutable reference is one that you theoretically cannot change. And a mutable reference is one that allows you to mutate the data. This, unfortunately, as a mental model, falls down if you start talking about interior mutability. Let's go look at like ref cell, etc. So cells. If you start talking about interior mutability, you start talking about data that you can mutate through a shared reference. So it no longer is really an immutable reference in that respect, right? Because if you can have a shared reference to something and you can access the data through that shared reference or immutable reference or whatever you want to call it, and you can mutate that data, then it doesn't feel like a mutable reference is the right word to use, right? So if we start referring to these things as shared references, which can have multiple people using them or multiple pieces of code using them at the same time, and exclusive references, which can only have one user at a given time, that's really what they are, right? I guess if we're going to say read write, let's say read. If we're going to say read write, we can say, or sorry, if we're going to say read only, we can say read write access to the variable. to pass a reference, we kind of also have to change what we have here. Right? Like we can't pass a reference to a thing that expects ownership. And maybe we talk about deref coercion here. Don't know. Two kinds of references in Rust. Shared references indicated by n numbers. Exclusive references. Shared references allow many users to access the data at the same time because none of them are modifying it. Or rather, how do we reframe this? Right, because how do we reframe this so that it works for interior immutability as well? Because it's really like when you use an arc and you want to mutate something inside of the arc, it's really an arc mutex, right? It's an arc and then a mutex inside of it, which allows you to use the mutex locking functionality to ensure that you are actually the only owner. Right? Mutual exclusion primitive for protecting shared data. Shared references allow many users to access the data at the same time. I don't want to say this. I don't want to say that because it's not true. It's not because they're not mutating the data. It just is. Right? We can rewrite our almost always arc mutex, but if you need to mutate, I use an arc for some immutable data just the other day. Yeah. So every handle in Bevy is an arc, not an arc mutex, just an arc. Right? There's a lot of cases where doing that reference counting is super useful, and you really only ever need read-only access. For example, in Bevy, if you have a handle to some asset, you don't need to mutate the handle, but you can use that handle to get a mutable reference to the actual asset, right? So arcs are super useful in general. There are even people who like advocate things for like arc with a string slice inside of it. So like arc stir instead of string slice, shared reference to stir. Somebody has a whole video on that on YouTube. We can rewrite our function to accept shared references as arguments, since we don't need to mutate the vec, and pass in shared references to the data in numbers. This lets us avoid cloning. Should we have talked about passing the vec through first? Does that drive the point home of move? Right, we've got this. If we pass the vec through and return it, then we can also call these functions. So maybe we add that as an additional. We can fix it in one of three ways. Cloning the data first, moving the data back out of the function by returning it, and sharing a reference, which allows a function to temporarily access the data. So we start with cloning, which just does whatever clone. Then we can do this and return the vec of I32. Unfortunately, I have to throw a shared reference into the debug to do this, which makes me feel like the example isn't as good as it could be. But we've already mentioned references at this point, so we can do a short call out to, hey, you can pass a reference here. Good morning. What's the plan for today? We're doing Rust language stuff today. Right now, we're in ownership. So we're talking about cloning and references, shared and exclusive, all sorts of stuff like that. Right now, what I'm doing is I've set up an example, right? This example here, where we've got a main function, numbers owns the vec, we pass numbers into some function, and we are using that to debug the actual data. We're then moving into the option to clone it. So basically, if you extend this program to use two of these functions, you can either clone the data to pass it in as a duplicate. You can pass in shared references in both slots, or you can move the data through a function and then pass the new data into the, or not the new data, but the same data move through each of the functions. So we covered cloning. And I decided just now that I wanted to cover moving through. We can also continue moving the data once we've moved it into the function by moving it back out. That's this program. It's so weird that that shows up on that monitor. Oh, well. Let's see. By moving it back out, the prints numbers function can take ownership Is that how I want to phrase that? of the vec. Return it from the function as a note, this does require passing a shared reference into debug so that debug doesn't take ownership, which we will cover in depth in the next section. I want to like include this as a little note. Is there like a little note box? Small caps. Maybe I'll look into some note formatting. TK, format this as a note. Doesn't debug return back the moved value? It does. You're absolutely right. So we could just pass it back like this to some extent, because it takes ownership, but it passes back a shared reference. So we have to remove the shared reference, and then it all works. We do have to explain that this happens if we do it this way, but I think that's fine. I did it this way originally because I think being explicit here is useful. But if I don't do that, then I don't have to make this note. And I think that that makes it better. Because then we don't have to talk about references until we're talking about references. So that's a good call out. We can continue moving the data once we've moved it into the function by moving it back out. The prints numbers function can take ownership of the vec i32 and then return it as the return value. The debug macro also takes ownership and returns the value it took ownership of. We can go through the ref, and after explaining, we can give back ownership as a return value. You can highlight that a debug gives back ownership and simplify the code. I don't think we need to go through the extra stage. I think we're trying to keep this compact. So just getting rid of it, because if you look at the headings, this is moving data through, right? So we're going to talk about that here. And then we immediately just talk about references, right? So if we're just immediately rolling into references, we can leave references to talk about in the next session. I like the flow of not putting a reference in here, because then it gives us a clear delineation of like, we're talking about ownership here, we're talking about references there. So remembering that Rust is primarily expression based, the value returned by the debug macro is in turn returned from the function. Does this explain enough about what's going on? Okay, we also need to since we're moving out of numbers, we have to create a new variable to own the return value of Print's numbers so that we can pass the new variable data into the second function. Since we're moving out of numbers, we have to create a new variable to own the return value of Print's numbers. This is what will pass this new numbers variable is what we will pass into the second function, moving the data again. So one thing that I feel like ownership pedagogical content kind of misses is this, like, yes, you can just keep moving it and 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 moving it. You can't access numbers anymore, right? After we call Print's numbers, you can't access new numbers anymore, but you can just move it, move it, move it, move it. Okay, I just got really hungry, so we're going to finish up this section and then I'm going to call it. Moving data through. We can also continue moving the data once we've moved it back in the function, moving back out. Since we're moving out of numbers, yada, yada. References. Passing a reference provides temporary read-only access to the value in numbers. While numbers retains ownership of the value. There are two kinds of references, shared references and exclusive references. Shared references allow many users to access the data at the same time. Exclusive references allow only a single user at a time. Rewrite our function to accept shared references as arguments, since we don't need to mutate the vec, and pass in shared references to the data in numbers. This all works. This lets us avoid cloning, creates clear expectations for the Print's numbers function. Maybe I want to say more about the clear expectations. Since the Print's numbers function only accepts a shared reference, it cannot mutate the vec. Right? And then maybe an aside about deref coercion. We haven't talked about string slices yet, but we can talk about maybe deref coercion and slices next. I will write that code here, right? Because this can now be a slice of i32s instead of a vec. We don't return here because that's not what we're doing. And this still passes into slices. If I name my variables correctly. Okay, so we'll talk about some slices. We'll talk about maybe deref coercion. I think we have to talk about deref coercion here. Deref coercion is like a big thing, right? If you pass in a slice and it can coerce to a different type, it can converse to a different type. So this vec that we pass in can coerce to a slice because it has a deref implementation. We haven't talked about traits, so I don't know how deeply we'll talk about deref. I'll put a link here for the moment. Right? I don't know that we will really talk too much about deref here. We also didn't talk about dropping. We should talk about dropping. Okay, we did a couple of things here. We got rid of those. We did those. Data has a single owner. We didn't cover copy semantics. Hey, Xavier, how's it going? Just finishing up here, actually. String and string slice. I don't know about common data structures going here specifically. I just said we were going to talk about deref coercion. I think this goes into this section. Actually, we start talking about common data structures here. But we should talk about move and copy semantics. And then where is our headings here? This is cloning, fixing the example. So this is a 2 heading. Section. Right, drop and copy semantics are going to go there. And then structs and enums is a new section. You just got here, but did you also introduce asref or just deref? It can be confusing for new coders, you suppose. We didn't talk about asref. We also didn't talk about deref yet. This is the first mention of deref. We did talk about references generally. This is not the deep dive. So I think what I'm going to do with that comment is put it into the there's an ownership here. We will talk about asref and deref. Right, because we'll talk about this stuff at a deeper level. I also like doing this like shorter video first because it kind of like really concretely draws a line through all the concepts. And I'll probably do an editing pass over this too. It, you know, like the sentences that I write on stream are not necessarily going to be the sentences that end up in the final copy. I might choose to pick out a couple of the higher level concepts and highlight them a little bit more. But I think we made good progress today. Today we have, where is it? We basically did Rust is an expression-based language and data is owned by a single variable. So we did ownership and expressions today. I guess this outline looks a little weird with a fixing the example there. If this whole thing is going to be all under one heading, then I think that we can kind of get rid of this extra level of indentation. The data is owned by a single variable. Did my little process die? Oh, it did. I made a mistake in my DREF link. There we go. Maybe we don't call that fixing the example. It looks a little weird in the outline. We'll call this working with ownership. Right, data is owned by a single variable, working with ownership, cloning, moving data. Through is a weird. References, deref coercion and slices, drop, copy semantics. I think that all fits. We're up to 19 pages already on this thing. This is just going to end up being a freaking book on its own. That'll be hilarious. All right, I think that's it for me for today. Thank you everyone for hanging out. And I will see you probably tomorrow morning. I'm really enjoying streaming. Tomorrow we'll probably do more Bevy stuff. In the meantime, if anybody wants to join the Discord, join the Discord. Which is where I put a bunch of the code examples and links and stuff. And I will see you all tomorrow. Thanks for hanging out.